let me actually up. Yeah, there we go. Okay, so we are live. Hello, everyone. And so today I'm here with Yadu and Julian. They need no intro, but I still think we should make a quick intro for the people that are joining us, and we'll get going. So Yadu, do you want to start?
Absolutely. Firstly, thanks for having me here again. It's a pleasure to connect with the Zetoscale audience and also share about all the cool work we've been doing with RMW Zeno. So I'm Yadu. I'm a software engineer at Intrinsic, formerly at Open Robotics. I have the privilege of working on core ROS2 development. I've served as the ROS boss for Iron or Winnie and currently help maintain the releases for Rolling Ridley.
Okay, thank you, Yadu. Julian.
Hello everyone, I'm Julien Hoc, Senior Solution Architect at Zetoscale, committer on Eclipse Zeno, and also contributor for the robotic use cases with Zeno, with RMW Zeno indeed, but also with a bridge from ROS to DDS to Zeno. And yes, working from the very beginning with RMW Zeno, and happy to share what we've done during the last year.
Okay, so, and again, I'm hosting this webinar, so today will be mostly you guys talking, which is great for me. It's a pleasure to have both of you on our webinar series, and as usual, I'm Angelo Corsaro, CEO and CTO for Zetoscale. So guys, we are coming from very far, right? And I think it would be good perhaps to summarize the various steps, okay? So as I start sharing your screen, I mean, would be great perhaps to do that kind of summary, right? To try to explain, where it all started, where we went, and how we got here, and perhaps we'll then we'll wrap up on what some of the plans are for going forward to make the RMW stronger and better. So, Yadu.
Absolutely. It's been such a long and fun journey that we've been on. I think we embarked on this endeavor almost 2 years ago when we started to take the complaints we were hearing from the community a bit more seriously. And the complaints were mostly around performance of transport over certain types of networks. And we really started reevaluating middleware choices within ROS2. So back then, the team, including Chris Lancet, and I started looking at what are the potential alternative middlewares that we could use in ROS2. And we conducted this exhaustive study, identified several suitable alternatives. We had some criteria we wanted to evaluate against while ensuring that not just our concerns as maintainers are met, but also those of users are satisfied. And from this giant study that we did, we kind of selected RMW Zeno, or I should say we selected Zeno as the transport to build a new middleware on top of. And this was announced shortly before the ROSCon of last year. And then we spent all of last year essentially developing RMW Zeno. And turns out it takes quite a bit of effort to develop a new middleware in ROS2, especially when we want to get it to a Tier-1 status. And I'll talk a bit about what that really means. But it's been a fun iterative process in trying to integrate Zeno into RMW. It's helped us identify a lot of assumptions we've made about certain middlewares and some biases in the APIs that stem from existing middlewares that we support. And overall, it's been a huge improvement to the ROS ecosystem. And I'm sure Zeno as a transport has evolved from the feedback from ROS users as well.
Absolutely, yeah.
Yeah, because we started actually more than 1 year ago the developments with a pre-1.00 version of Zeno.
Indeed, yeah.
And all the very first experiment we had with RMW Zeno leads also to improvement we integrated in Zeno 1.00.
Absolutely. I mean, improvement, I think we accelerated some features that were not available on all API. So all in all, I mean, I think it was great for us because, again, we added coverage to new API that wasn't there yet. I think we did some work in improving performance, improving scalability. There were some deployment scenarios that weren't, I would say, typical for us.
Yes.
That we worked in making, in supporting them strongly. We did some additional work on shared memory. Yeah, so it has been a great collaboration. And I think, it's always challenging. That's nice. I mean, when you get new challenge, that's how you get to the next level. And so that's what we like. I think this is what you guys like. So let's keep, taking on board challenges and improving the status quo. Yeah,
absolutely. Yeah.
Absolutely. So with that, I'd like to present a couple of quick slides that details some progress. And as you can tell in the title, the big announcement from our side from this year's ROS release, which is titled Kilted Kaiju, is that we now have a new Tier 1 middleware. And this is, of course, RMW Zeno. So I'd love to spend some time talking about what Tier 1 means and how we got to this step.
Yeah.
It's a big quick introduction of myself. I'm going to skip over that. Just to give some additional context, like I talked about this journey we've been on for almost 2 years. And I think at ROSCON Odense last year, around October, we announced that RMW Zeno is a feature-complete middleware. This means that it supported all the basic elements of the middleware, hub, sub, services, clients, actions, etc., but wasn't yet at Tier 1 status. And then we had a follow-up update towards the end of the year in December, where we announced that RMW Zeno is now based off of Zeno 1.0. And we also support Windows. We had a lot of other tests that we were able to get passing, but there was a long way to go. Right. So we kind of outlined this journey to Tier 1 status, and we boldly claimed that we would have this ready by May this year for the next ROS 2 release. And one key element of this is to get all the core tests to pass. And I'll talk a bit about what those core tests are down the road. Some other challenges we faced was not only being able to get the test to pass locally, but we have a lot of CI jobs we run, not just nightly, but also during anytime we test a new pull request. And when we run these CI jobs, we also want to run it against RMW Zeno. And then we had to also figure out how can we get the router to start when we run these jobs. And more importantly, we also had to fully integrate with the SROS2 workflow. So SROS2 is a framework that helps generate security artifacts for anyone using ROS2. So it generates a set of configuration files that can be passed down to middlewares to enforce things like access control, encryption, and authentication. So our goals was to make sure that this workflow is supported for users working with RMW Zeno. That would be important to get it to Tier 1 status. And since then, I think everyone's aware that we managed to achieve our goal. So we can proudly claim that RMW Zeno is a Tier 1 supported middleware in ROS 2. And this is officially enshrined in this Rep 2000 document. So this is a document that describes for every release, what are the supported platforms, what are the supported middlewares, and what are their support levels. So tier is essentially a support level. It comes with certain privileges. Being a Tier 1 middleware means that you have the privilege of running nightly CIs on our build farm. You have the privilege of getting our attention anytime there is a major bug fix. There's a problem that needs to be resolved. And most importantly, that it has to be supported on all the platforms that the distribution is released on. So in this case, it's Ubuntu Noble, Windows 10, RHEL 9, at least the Tier 1 and Tier 2 Tier 1, Tier 2 operating systems. And Tier 3, of course, is community developed or maintained. So we've been talking about this Tier 1 quite a bit. So what does it actually mean, right? So I mentioned that Tier 1 elevates the middleware to a privileged status in the ROS ecosystem. And this essentially means that we're running nightly CI jobs on it. We ensure that any critical issues are addressed immediately. But for users, what does it really mean, right? That they should feel confident in using RMW Zeno, that it's been put through the ringer. It goes through all our core tests. It has security integrated. It's on all the Tier 1 OSs. And we have quality declarations for the package. And more importantly, it's officially part of the core set of ROS 2 packages. And here's an exact description of what Tier 1 means. I'll just leave a link to it so someone can reference it afterwards. But as I mentioned before, the focus here is on the attention it gets from the developers. In order to become tier 1, you first have to be part of the core package set. So in ROS2, we have this ROS2.repos file. Think of this as the source of truth for what makes up the core set of packages in ROS2. And there's a formal process in being able to get it in there, which includes making sure that it has a quality declaration. It supports all the tier 1 middleware features. It passes all our tests, etc. But this is also a big achievement that we've had over the past few weeks, where we've gotten RMW Zeno part of the official list of core packages. And so what does this mean on a day-to-day? So anytime someone opens a pull request against one of our core packages, RCL-CPP, for example, which is the most popular client library, or one of the most popular client libraries in ROS2, we would run a CI job to test the changes being introduced. And when we run the CI job, we're essentially running tests up to this package. And a lot of these packages could choose to define multi-RMW tests. So they're not just testing against the default middleware, they're testing against all the middlewares in the core set of packages. So in this process, every PR gets tested against RMW Zeno. So it's another area where RMW Zeno is proving itself that it's ready for anyone to start using. But most importantly, and I think what users are interested in is hearing that RMW Zeno is, well, let me rephrase that. Every test from every core package is tested nightly against RMW Zeno. So if you look at the statistics, this is almost 40,000 plus tests that run nightly, right? And you can tell that all the tests are passing. In this particular case, there's been one flaky test, but it's still extremely impressive that for a brand new middleware that we introduced, we're able to see almost all tests pass consistently.
Yeah.
This is incredible. Yeah, and over the past few months, we've made so many improvements to RMW Zeno, both benefiting from the upgrades of Zeno itself. So now we have Zeno 1.4 that's powering RMW Zeno, and with it, all of its optimizations, performance improvements. But within RMW Zeno itself, we've made some critical fixes and improvements that should make performance a lot better. We've switched to Zeno CPP to better address some threading issues that we encountered with Zeno C in the past. We've been able to provide better end-to-end reliability through this heartbeat sporadic feature that was introduced in Zeno. We now support the ability to override configs from environment variables. Yeah. This is something that had to be tweaked manually through configs in the past, config files. And it's great that now users can just set an environment variable and alter the behavior of their transport. Along the way, we've also fixed a lot of bugs. And more importantly, we've introduced this new package called Zeno Security Tools. As I mentioned previously, integrating the SROS workflow or having it work with RMW Zeno is critical for Tier 1 status. To aid with that, we've introduced Zeno Security Tools. It's a package with an executable, and it helps us generate config files, Zeno config files, with the appropriate access control, authentication, and encryption settings based on policies and key stores generated using SROS2. So this is already a standard workflow for ROS2 users today. They use SROS2 to generate key stores and security policies. And then typically you pass these configuration files and parameters to the middleware. But with Zeno, we've found a nicer way to do this, where we could just update the existing Zeno configs, and users just point to those configs when they start their sessions and routers. We also have a tutorial on our official documentation site, docs.ros.org, with how users can run RMW Zeno with security enabled.
Cool.
Last but not least, I want to highlight this effort we do during every ROS release called the Test and Tutorial Party. So before the release, we make sure that the new distribution is extensively tested by not just the core team, but from a large group of community developers and supporters. So we put out this call for testing, and there's a whole bunch of tickets created where we test all core functionalities of ROS2, all the way up to higher level applications, building things with RViz, etc. And we do this in a combinatorial approach. So everything we want to test, we test for every single operating system that we support. We test for every combination of middleware plus operating system we support, etc. So for this year's tutorial party, RMW Zeno was part of this mix. So there were hundreds of tests generated evaluating core capabilities of ROS using RMW Zeno that were validated by community members. So it's not just the development team that's kind of putting a stamp on this, but a lot of community members have had a chance to run with RMW Zeno, and we've had great feedback so far.
So a big thanks to the community to test all of this and to report the result of the test.
Yeah, and I think at the party and even throughout the development, it was nice to see the engagement that built from the community, experimenting either just with code or with code in robots. And I think that was essential, right? Because ultimately, this has to work in robots, right?
Absolutely. Yeah. We're starting to have feedback on real use cases, which are working quite nicely. Yeah.
And I believe that was my last slide. I did want to quickly talk about what's next. So we are at tier 1 status now. RMW Zeno binaries have been released for quite a while. So the binaries are available on Rolling, Kilted, Jazzy, even Humble. But this is a project that will continuously evolve over time, and we're always thinking about how we can improve the experience for our users. And one big feature we hope to land over the next couple of weeks is support for shared memory. This has been a much awaited feature from a lot of community members, and we've been going back and forth quite a bit on landing this PR, and I think we're pretty close. So once this lands, it may not be the default, it may not be enabled by default, but we're hoping a lot of community users can help us test, find problems with it, maybe help us tweak configurations, and then we'll make the decision on whether to make it default or not down the road.
Yeah, and we're also very much looking forward to it. We tried, again, we discussed this a lot. Obviously, there are lots of concerns, but hopefully, what we have done will address most of the use cases. And we have now a fail-safe mode, right? Because first of all, there is nothing centralized that you need to configure. Every process comes with its own shared memory segment. And you run out of, in a way, shared memory, you fall back, just not use shared memory, but you won't crash, which is nice.
Yep.
And in this version, it's completely transparent, right? So very much looking forward to how the community will find this. So
it's available in Rolling development branch, but we also made a port on Jazzy branch. So right now people can already test it, building from sources with this Jazzy branch. So
and some people are already testing, which is great. So we want more of this, right?
Yes. So for those curious, the pull request is number 656.
Just post it on the chat.
Post it on the chat.
Great. Yeah.
So user can test it directly on Jazzy.
Exactly.
Absolutely. The second thing we want to look at are performance improvements we can still make. I think there are many ways we can improve or reduce the bandwidth we're currently consuming, maybe even the CPU usage on resource-constrained devices. And we hope to achieve this by making our key expressions more compact. There is quite a bit of redundancy in there at the moment. We want to be very careful, but maybe there are ways to optimize the length of these key expressions. And finally, we also rely on this concept of attachments for several parts of our stack, from keeping track of sequence numbers of publishers to information or metadata needed for services and clients. There may be ways that we can get away or making attachments optional. This would mean that users of Zeno or Zeno Pico on microcontrollers can better interoperate with RMW Zeno systems,
while really maintaining minimal memory usage, which is what we want to do. And well, as again, we like challenges. We'll address also this one, right?
Indeed, yeah.
Cool. Okay, Julian.
Yeah.
Let me.
Thank you. So
thank you very much, Yadu. And as I share Julian's screen, which should be this one, we can hide that one.
Yeah, so let's have a look on how to get started with RMW Zeno. So just first reminder, right? In ROS 2, you can have several different middlewares installed. The default one being FastDDS, but still you can switch, change the middleware that your application is using, because those are just packages that you can install in on your host, right? Zeno RMW Zeno is based on Zeno, indeed. It's using Zeno CPP, which itself used Zeno C, itself based on Zeno developed in Rust. And the availability of Zeno, so as you mentioned, Yadu, it's indeed Tier-1 supported in Kilted Kaiju, but we also backport all the developments we made for RMW Zeno to JZ, the current long-term release, and also to Humble. As an experiment, it has not been intensively tested on Humble, but I think all the pull requests have been merged to Humble, so it shall work exactly the same. With just the type support, the type hash were not implemented in Humble yet
because it's a new feature.
It's a new feature, so just be careful with to have the correct, the exact same type definition for all your topics, right? Because there is no guarantee that you will not have a crash if the type differs on a same topic.
And just point out that here the only distinction between Jazzy and Kilted is the Tier-1 status on our CI systems and build farm. In terms of quality of code and features, they're probably the same. Actually, they are the same.
Yeah.
The only difference is that we have the infrastructure in place now to be able to run RMW Zeno on our nightly CIs for Kilted rolling onwards.
Yeah, absolutely. Yeah.
And by the way, so as you mentioned that we have received that question already a couple of times, and maybe you guys too. So maybe we can answer it now. So we take more people in the same shot. So the question we've received is, what is the status of Zenoh RMW in Jazzy? Is it Tier-1? Because we said, okay, look, we don't know. Well, I mean, on theory, right? From my perspective, on theory, Tier-1s means it has been voted to be Tier-1. So, procedurally isn't Tier-1 from my perspective. But then what would you say?
Yeah, I would defect back to the definition of Tier-1. It's two things, right? It's privileged status on our build farm and CI systems. And two, it also gets our attention, and it has, we will prioritize it for fixing bugs and making sure that it's building on the build farm. While we do that for Kilted, it's not necessary that we may do that for Jazzy, but the software quality is the same. So the performance on Jazzy will be exactly the same as Kilted.
Yeah. And I think that, however, even if somebody raise an issue on Jazzy, right, we will have a look, and this issue will probably also occur on Kilted.
Maybe.
So anyway, I think we will have roughly the same process in order to fix the bugs for Jazzy and Kilted. But as Yadu mentioned, it's just that mainly the build farm is not made to run RMW Zeno on Jazzy.
Yeah,
exactly.
Okay. Thank you for the clarification, and hopefully that clarified or answered the question for other users, as we have had that question in the last week 3 or 4 times.
Absolutely, yeah. So installation of RMW Zeno, well, it's quite simple when you're on Linux, right? You just install the package RMW Zeno CPP from ROS2 Debian repo with the apt command. And then you need to set the RMW implementation environment variable to RMW_Zeno_CPP. And this for all your system or for each shell you're using. So better to, if you definitely want to switch to Zeno, better to have this variable export in your bashrc or in your
ZRC or whatever.
Whatever shell you're using. Yeah. And then you can already do a quick test to check if everything is running, installed and running smoothly. First, you start the Zeno router, which is named RMW Zeno D. So that's a ROS, that's a built as a ROS package. So it can be started directly with the ROS2 run command. And you can start the simple talker and listener demo, for instance, with the typical ROS2 run command for talker and listener.
Yeah.
And this shall work. So, but the main question we have for newcomer from DDS is, why do we have a Zeno router? Well, first point, the choice was made to avoid to use UDP multicast with this new alternative middleware, because in the past, a lot of newcomers to ROS and to DDS has issues with UDP multicast, which is the default transport used by DDS. And so, not having UDP multicast, we avoid newcomers' issues with misconfiguration of the network or misconfiguration of the OS, and even issues with potential issues with Docker or Kubernetes environment. And also, we prevent this way uncontrolled communication. Because, for instance, in education, if you have a classroom with full of students experimenting with different robots, 30 robots in the same LAN, well, they will by default discover each other. If they are all by default using the same ROS domain ID, they will all discover each other, and it will be a mess. So with this new middleware, at least education will have a smooth experience just using Zeno. Everything is under control, and no cross communication are accidentally caused. So why the router then? Well, first for discovery. If you don't have UDP multicast, you need something to act as a rendezvous point on which all your nodes are connecting to.
Could have been a node.
It could have been a node.
Could have been a node, but there are more reasons why you want to have a router.
So the router is acting as a, let's say, discovery service. All the nodes are connecting to this discovery service. There is what we name a gossip protocol, which is run by Zeno. Zeno forward all the locators of each node to all other nodes, and then the node can establish peer-to-peer communication over the loopback. And then, you're right, second benefit of the router is to actually route all the communication to the external of the robot. Why? Because the benefit of this is that you have less external communication, right? You don't have peer-to-peer connection across all the nodes between different hosts, which can lead to a lot of overhead. Zeno can perform some batching. If you have very small messages that are sent over the external network, like the Wi-Fi, for instance, Zeno will batch all of them in a single big messages, so improving the throughput. You have a smaller surface of attack because there is only one listening port in the robot, and you can configure this port to use TLS or mutual authentication with TLS.
Or Quick.
Which also uses TLS. And you can also configure in a single point the router some access control and downsampling. So just to smooth all the communication outside the robot and to save some bandwidth.
And by the way, another nice feature that we added for ROS, right, was the ability to change on the fly QoS and to assign dynamically priorities to specific ROS topics, and in fact to key expression.
Absolutely.
Which was something we didn't have, and I think was a great addition that came from some needs.
Absolutely. It's quite an important one, because, for instance, when you have a reliable topic, which by default in Zeno will lead to have some mechanism that we name congestion control block, meaning that if the network is congested, the writer will slow down to make sure that the subscriber get all the messages. While you want this inside your robot, you don't want to miss a single message for reliable topic inside your robot. When you're subscribing over the Wi-Fi, it can cause issues, right? Because if the Wi-Fi is slow, it will slow down the publisher in the robot. So with this possibility, you can configure the router to change on the fly the QoS when routing over the Wi-Fi to change to best effort.
And in general, it's the recognition that inside and outside the robot are two different worlds with two different dynamics and sometimes different requirements. So, and again, I think this is an example of co-innovation where the needs of the robot have pushed a certain feature on Zeno that then are benefited by obviously ROS and all Zeno users. So this is great, right?
So there is a Zeno router. It means by default in the default configuration, there is no usage of UDP multicast. All the communication inside the robot are occurring over the loopback by TCP. All the discovery is made by RMW Zeno D. And RMW Zeno D, the Zeno router, is listening on all available interface for incoming connection. So it means, well, by default, indeed, RMW Zeno will work in a single host, right? To make communication with another host, you need to tweak the configuration. But how to configure Zeno? Well, there are default configuration files, and in the installation, they are installed with the RMW Zeno package. So it means they are you can see those default configuration files in this path /opt/ROS/ the name of your distribution /share /RMW Zeno CPP package /config. Here you will find two files. The default file configuration file for the router, and here I just extracted the key points with regard to communication from this configuration file. So the router is indeed in mode router. It doesn't connect to anything. You see the connect endpoint is an empty list, meaning by default it doesn't connect to anything. But it's listening on TCP on any interface. This column between the bracket means any interface in IPv4 and IPv6 on the port number 7447. And then the gossip scouting protocol is enabled, and with the auto connection allowed for peers to routers and routers to peers. For the session, so all the nodes will use the default RMW Zeno session config, this config file. The nodes will automatically connect to the local host interface on port 7447, which means they will connect to the local router, and they will listen on the loopback only on port 0, meaning let the OS to choose the port. So it will be a random port, right? But it means really that by default, all the nodes can only be connected via the loopback. So there is already a built-in security, which means that nobody can connect to the robot directly to a node. It needs to go through the router, and the router is a gatekeeper for your robot communication. So the nodes are connecting to the router. The router is running gossip discovery and gossip scouting, and the node will connect to each other, and everything will be working.
By the way, maybe, I don't know if you're clarifying this next or now. The router is not used by the node to communicate, right?
Absolutely.
That's an important point.
Yeah.
You can start technically things in any order.
Absolutely. Yeah. So once the nodes are interconnected, they indeed are communicating only peer-to-peer.
Yeah.
The router can crash. You can restart it.
No problem
at all. The nodes are still going to communicate with each other. Once the router is restarting, they will automatically reconnect to the router, and everything is working smoothly.
And the other important thing is that off the shelf, right, we are configuring TCP/IP, but any of the supported link could be used, right?
Yeah.
And there are plenty. So if you wanted to use pipes or Unix
shared memory
or Unix domain socket and so on and so forth, right? Or quick or whatever. Yeah, that's just a configuration change.
Yeah, configuration change, and you have all the details of configuration. Maybe I can show exactly what the full configuration file look like. So you can see it here for the router, for instance.
You can increase just a little bit the font, and I'll move back to this visualization. So actually, this is better.
Let me change this. So this is a configuration file for the router. You can see here the mode router, but you can see also all the comments we have explaining all the points with regard to configuration. So we can see here the connect structure. And in the structure, there are more configurations that I shown in my slide, but we can see here the empty endpoint list for the connection. In the listening part, which is here, we can see here the endpoint. So it's listening on any interface on port 7447. And then there are a bunch of other configurations that you can tune and configure. Also, for instance, multicast scouting, I will talk later.
It's disabled, right?
It's disabled by default, but still, Zeno supports UDP multicast discovery via multicast scouting, and I will show later in a slide how to configure this. Okay. So, and then the other question: shall the router be started at first? Shall it be started manually? At this stage, yes. It needs to be started manually, not necessarily before all the node. You can start the node and start the router later. The node will just wait for the router to be detected, to be discovered.
Yeah.
You will have a warning, a periodic warning saying for each node, I can't find the router, I'm waiting for the router. So, but once the router is started, all the nodes will connect and will interconnect with each other, right? Okay. So how to change the default configuration? First option, you go through config file, you copy the default config files, and you edit them. Why to copy them? Well, to keep all the default settings that we are specifically setting for us.
Yeah.
Right. There are a bunch of timeouts that differs for the original Zeno default configuration, which are specific to us. So better to keep all this default configuration specially tuned for us too. And then once you copied and edited your file, you change the file for what you want. You can define environment variable with a path of the config file you changed. You have two environment variable, Zeno router config URI and Zeno session config URI. And as Yadu also mentioned, we recently added another environment variable that you can combine with the environment variable for file to override some setting for specific nodes or just for the router. This is the environment variable Zeno config override.
Yeah.
And here is just a string. You need to set the exact field from JSON you want to change the value using / as separator and equal, and you set
whatever the value is.
Yeah. And you can set several value, just separate them with
so for instance, I mean, if it would be a listen endpoint, would be listen/endpoints equals, and in that case an array, right?
That's exactly what I will show.
Perfect.
In the next slide here. So because you have your robot, it's communicating locally, but it's from your laptop, how to monitor and supervise your robot.
Yeah.
Well, first an easy point, you on your laptop, you start also at Zeno router, and you configure this Zeno router to connect to the Zeno router of your robot. So here I set a simple example with a Zeno config override. So you set connect / endpoints, and then the array of endpoints you want your laptop router to connect to. Here there is only the robot to connect to, and then you run the router. Then you can run all the usual tool, ROS to client, ROS to topic list, ROS to node list, RQT, teleop, RVs, whatever. Okay, but do I really need to run a router on my laptop if I just want to run RVs, for instance, because it will be an extra hop, right? So there will be a little increase of latency, not a very big one, but still it's a burden for nothing. So no, you don't need to have a local router on your laptop. You can perfectly directly make a node to connect directly to the remote router. And for this, you use the same Zeno config override setting to change the connect endpoint to the router of your robot. And you can run your RVs node or whatever node. Just be careful with ROS2 CLE, the ROS2 node list and the ROS2 client list. You may be aware that it's using underneath a ROS daemon, which is started automatically for the first time, right? When you start first time you run it. If you run it when there is a router, this node will assume there is always a router. It will only connect to this one. So, and when you run again ROS2 topic list, it will ask the daemon, and the daemon will not discover the remote robot. So whenever you change the configuration of routers and so on, better to stop the daemon, or also you can just run ROS2 CLE with a -- no daemon environment variable setting arguments. So it will not use the ROS daemon, but directly call the appropriate endpoint. Okay, I can connect one robot, but how to connect several robots? Well, here another example with configuration files this time, right? Because it's more, well, just to change and to explain how to do it. So two ways to do this. Either you have your fleet manager to connect all the robots. So you configure your Zeno router in Fleet Manager with a list of robots as endpoints to connect to. But you can do it also the other way around, right? You can configure each robot to connect to the fleet manager.
For instance,
so, actually, that's maybe a better idea, because in this way you can have as much robot as you want. You don't need to change your fleet manager configuration to connect more robots, right?
And then what is my favorite way, right? You run Zenoh on your access point.
Right? That's another point that you can show in, like you can see in some webinar that you made, Angelo.
I often, when I do the demo, I always have Zenoh running on our Wi-Fi access point, so you can do that easily. Building, we should explain how to build it with the target for OpenWRT. It's pretty straightforward. It's just a cargo cross compilation, and it's a breeze. So and maybe I'll cover it. I'll part of one of the latest episode of the advanced tutorial.
Good idea. So you can have a Zenoh router running directly in your Wi-Fi hotspot.
Exactly.
And everything.
And that's actually the best deployment in terms of performance too.
Okay. Now, what if I don't want to bother with all of this and I want to go back to DDS style, where everything is discovering to
and again, you have to be careful when you say this, because Zenoh, I spent 1 hour on our last webinar explaining how Zenoh discovery works, which is very different.
It's very
so there is a link on the chat. Watch the webinar. It's scouting, not just discovery.
It's scouting, exactly. There you're good to point this. It's actually router scouting in Zenoh protocol.
And scouting is just about, it's a very small message, which is a scout message, which is a couple of bytes, where you can search for specific kind of runtimes, because there is a what you're looking. And then it's just a way of finding endpoints to bootstrap that Zenoh, everything else in Zenoh.
Exactly. So how to make the router to automatically scout each other and to connect to each other? Well, you can enable multicast scouting with Zenoh via the config file. And by the way, there is a typo here that I will just fix. It should be true indeed.
Exactly.
So you change the configuration via the config file. You enable multicast scouting, and you configure the autoconnect for router to autoconnect to routers. So router will allow to autoconnect to router. And you can do it also via Zenoh config override, and there is a way here. It's a similar configuration, right? But this time you have two settings: scouting/multicast/enable true, and scouting/multicast/autoconnect equal router. And that's it. And you run your router, and the router will automatically perform multicast scouting and autoconnect to each other in your LAN, right? In the LAN only, because UDP multicast won't cross the WAN and the NAT.
And again, you can even control with the time to leave.
Yes, there are more settings. Exactly.
You had it in the previous configuration.
Yes, in the multicast scouting here, you can change the time to leave. You can change the multicast address. If you want to have several group of discovery, just change the multicast address or the multicast port, and you can scope the discovery in different groups with each other.
And even on a single robot, because something else that could be done, this is a question that we also get asked very, very often, right? If you wanted to have a deploy, suppose your robot never communicates with anything else, right? It's a standalone robot, and so maybe you don't want to use a router because you're never going to communicate with the outside. Then they could still enable multicast only for the loopback.
Absolutely.
And so and I think something worth, right, is that the default configuration is what will work for 80% of the cases, and it's probably the best, right, Yadu, for in terms of out-of-the-box experience. Absolutely. But then there are tons of knobs, right? And the principle is that what you need, it's highly likely that you can get by getting the right configuration.
And if you're a more advanced user, you can precisely tune as per your topology or use case requirements, which is fantastic.
Exactly. So no topological constraint, as we always say.
Okay, then as you mentioned, everything is running on one host over the loopback. But what if I have a robot with multiple hosts? For instance, a nightmare, which also have a robotic arm. The robotic arm is usually driven by another host, maybe a Raspberry Pi or something else. So, two things. First, it's better to have only one router, right? Because you want only to have one router routing over the outside, but internally, as probably the AMR on your robotic arm are linked with an Etherlink link, or just Ethernet over USB, for instance.
Could be serial in some case, right? Whatever it is, yes. Yeah.
Well, for more multi-host, it will likely be either Ethernet with a switch, either USB-C over Ethernet. And so you have two hosts with two different IPs. And maybe if you have another if you have a Wi-Fi interface, there will be a third IP for the Wi-Fi, right? So you will deploy only one router, and you will deploy it on the host with the Wi-Fi hotspot, the Wi-Fi interface. And you need to configure all the nodes to listen on the Ethernet interface, right? Because they need to listen on the Ethernet interface to connect to each other through the Ethernet connectivity. And you need to also to configure the node on the ARM node to connect to the router in the AMR. So the router will perform the gossip protocol between all the nodes, whatever the hosts there are, and the node will automatically connect to each other via the Ethernet interface. So for this, you change the session configuration. In the ARM, you listen on your own interface. So here, interface ending with number 2.2. You connect to the router on the other node, the AMR node, so interface number 2.1. And the nodes on the AMR, they are also connecting to the Zeno router on the same host, so IP ending with 2.1, and they are listening on the same interface, IP ending with 2.1.
Yeah.
And by the way, I'm mentioning IP addresses here, but Zeno can also resolve host name, right? So if you configure the host names, just replace IP addresses with host name. That's
and there is actually a nice trick here. Should we reveal it?
Which one?
So in the listen, you have a port 0.
Yeah.
That's a good trick, because if you don't specify the listen endpoint, right? Because in here we are saying, well, you are bounding an interface, but not binding any port. The port will be chosen. There are two advantages. Obviously, you are saying which interface, because if you don't say which interface, then by default, Zeno will be listening on all available interface. And this information is distributed, right? So in modern machines where we have 1 zillion virtual interfaces, that can be a lot of data, right? So it's always a smart idea, if you know through which interface you're going to communicate, to put a listen that looks precisely like this one, with the IP address of the interface and the 0 port.
Indeed,
Because that way you will have just, especially if you're using link state routing or gossip, you will have just one locator flying, as opposed to a zillion of locators that are not so useful in some instances, but we can't tell, right?
Yes, indeed. So better control and better optimization.
Exactly.
With regard
so that's a good idiom. It's a good trick. Yeah.
Okay, and well, that's it for today.
That's done. No.
I was learning so much.
We're almost reaching the hour, right?
Almost, but I was having fun.
Probably,
so that's
well, if you want to know more, actually, we may have some workshop very soon.
Yeah, but first of all, there is a little surprise, guys. So let me share. Yeah, of course. Right.
Oh,
you're seeing it before, so let me share it with everyone else, because this will be distributed later on to everyone else. But I think it's for our community that is joining our webinar, and okay. So here is the surprise.
All right.
Special Kilted
So do
edition.
you like it? Yeah, that. I mean, you were expecting this, right? So this will go out officially with our with our newsletter, because now we have switched to quarterly newsletter. Isn't it cute?
This is amazing.
This is the least we could do, right? I mean, they look great together.
A nice one, yeah.
Okay, so, and again, thanks again to our designer. He's very creative. Francesco, I mean,
very nice.
It would be nice. I mean, it's sometimes we should, next time he's in Europe, we should ask him to join the ROS conference and do live cartoon for the conference.
There will be a queue to be signed.
That would be cool. Yeah. Okay, so let's get back to us now. Little surprise aside. And let's try to draw some conclusion and wrap up.
And maybe if there are any questions, feel free to ask any question now. And
so let me actually stop sharing also the screen up. Yeah, so we go back to our view.
A thought that just came to mind, I think the timing of Kilted Tier-1 release, RMW Zeno being Tier-1 release on Kilted, nicely overlaps with us sunsetting the ROS1 distributions. So users coming from ROS1 should be slightly familiar with this topology of starting a router or starting the ROS master equivalent, ROS core equivalent here. But they would be surprised to see the differences in behaviors. We're more resilient to restarts. We have a lot more features that the router can enable. So it should be a welcome change for users migrating from ROS1 to ROS2.
Absolutely, yeah.
Okay, so right now we don't have questions. I mean, the presentation were very clear. So if anybody has any question, don't hesitate.
I'm pretty sure we'll have question in the coming days anyway, either on Zeno Discord, either as issues in RMW Zeno. You can still post question also
absolutely
on GitHub.
Absolutely, yeah.
And and we plan to attend some ROS conference in autumn, right?
Yeah, absolutely. I mean, it will be pretty cool to be in Singapore.
Oh yeah.
Yeah. Okay, guys. Thank you very much. It was honestly great to have you both. Yeah. So hopefully I'll manage to have you again sometime soon.
Thank you, Yadu.
Great work. Great work.
Yes, a big thanks also to Alejandro, who couldn't attend today.
Unfortunately, yes. So and ciao, Alejandro.
Ciao, Alejandro. And to Chris Lalanset, who did a huge job in the past for RMW Zeno.
And the many others, right?
And many others, yes.
Because
Frederic, Francesco, from Ecumen, it's Francesco, right?
Francesco,
and and also contributors.
I mean, thanks to everyone who made this possible. Right? Yeah,
incredible effort.
Absolutely.
Getting so many fixes from community members as well. So we're very grateful for that.
And again, ad majorem, as we say in Latin, which means to more innovation and more improvements. Okay.
Coming soon.
Ale, thank you, Yadu. Have a great day. And thank you, everyone. Ciao. Bye-bye. Bye.